All right, continuing from where we left off, this video will be a bit of a in-depth dive in some relationships and some math, so bear with me. So the first thing we see here, in terms of coding, I will just give a quick overlook. We're going to see what things look like, and then we're going to dive into the math behind it. So we're just going to hard set the chunk position to the right neighbor, that being 1, 0, 0. So our already generated chunk is at 0, 0. This will now be 1, 0. That is just the chunk directly to the right. We have a new function named chunk neighbor check neighbor chunks, and this print tile options will be relevant later. If we dive in here, a quick overview shows that we see there's quite a bit of math involved with determining what we need to find information wise. Now, what is all of this math? I will give you a explanation, and then we will write it out. So this will end up being a 3-part because this is going to take maybe 10 minutes to explain. All right, so we have this chunk over here. We'll call this negative. Okay, we'll call this -1, 0, and this will be 0, 0, and this will be, you guessed it, 1, 0, and so on. This would be 0, 1, and 0, -1. So -1, 0 has already generated. Now we want to generate or collapse 0, 0. Now we need to somehow get information out of these tiles. We care about what's going on right here because that will affect how things should generate. We should end up with a generation that could very simple, could look something like this, where this will line up perfectly and maintain that continuity. Now, how do we do that? We need to find some relationships between chunks and between cells, and we'll call the neighbor cells. So 0 is right here. We care about its direct left neighbor. Now, what is that directly to the left? Well, we happen to know because our chunks are the same size, and this works and is based off the idea that your chunks will be the same size. If they're not, it probably could still be done. It's just about determining relationships, and you would have to figure out that for yourself. Maybe I'll do that in the future. It's unlikely. That would probably use various modulo functions, and just it'd be more complicated relationships. So because this is the same size, we happen to know 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we know directly to the left of 0 will be 9. And that's just the same here. And what is that relationship? Well, it is just the width of our chunk, which is 10 minus 1. That nets us a 9. Perfect. So that's very, very simple. So we'll call that x being the width. You know what? We're going to write a little bit of a legend here. X equals width y. Ooh. Y equals height. A equals neighbor cell. If you can't read that, that definitely says neighbor cell, I swear. Okay, so the relationship will just be x. We'll do relationships in green. That's fun. X minus 1 equals 9. Perfect. That's a very simple relationship, and that's what we're going to build off of. We want to know this first cell. Now, we want to know what would this cell be. And we happen to know, actually, this is just a little short. We're going to just copy and paste that one over it. Did I just do the same thing? I swear. Okay, good. All right, so what would be the relationship between 0 and its bottom neighbor? Now remember, this is what we've used in the past, left, right, top, bottom. That's my directions enum. We will still be using that. We have the left neighbor, the left chunk. The bottom chunk, the right chunk, the top chunk. Okay, what would be the bottom chunk neighbor? Well, we can imagine this as starting at 0, as it should, in relation to itself. This would be 10, 20, 30. I did 34. What? 30, 40, 50, 60, 70, 80, and 90. Now, what's the relationship between 0 and 90? Well, all that is just the width times the height minus the width, equals, in our case, 90. The width and the height are both 10. Minus 10 gets us to 90. That gets us to our starting point. So that's perfect. Over here on the right, if we want to get this cell, this will be, well, it'll be 0. And that's that. It's just 0. So that's all it needs to be for the right neighbor cell. If we will be starting at 9 in the generating cell, but we want its right neighbor, which is out of bounds, which is in that neighbor chunk, and its corresponding neighbor would be 0 within this this graph. And then similarly, if we were all the way up here, remember this is 90 up here. Do that. Will just be, you guessed it, 0. Perfect. So we've determined some numbers. And in fact, we will go ahead and code this in because this is very simple and I don't want this to get lost. Okay, so first thing we need to do within the check neighbor chunks, we need to do a for loop. This is going to be for each of the directions we have. In the case of a 2D environment, it is for, that is top, bottom, left, and right. So an index for loop starting at 0, ending at 3. Turn to byte, turn to that direction's enum promoted to a local variable. Using the direction wildcard, we will then input those numbers that we just found. So the top neighbor, this top neighbor should be 0. We're going to want it to be 0. And we see that here it's set as the neighbor cell ref if it's in the top direction. If you don't remember, we used this in the forward checking. It looks something like this on the inside. It just uses a switch to pull whatever information we want based off of a direction. Okay, if it's the bottom, we want this bottom cell. Remember, it was just width, height minus width. And we see that right here. Width times height is what's multiplied into there. X times Z minus another X. And then for left, the relationship we found was just width minus 1 gets us that neighbor cell. And that's right there. Width minus 1 is that left neighbor. For the right, that was just going to be 0. Perfect. And that needs to be promoted, like I said, to a neighbor cell ref local variable. Okay, from here, oh, I can't decide if I should make this a separate video. We'll just plow on. All right, so the next thing we need to do is we need to check if the chunk exists. In fact, it would probably be better to place this in front of that because we don't really need to be setting the neighbor cell ref if it doesn't exist. Though this is very, 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 very small computationally. So we have here directions goes into a function called find chunk in direction. Now, what have I done here? I've created a new function. I've selected pure. We don't need to do anything besides pure computations, so we can use this pure function where we don't have to use the exec pins. And we'll open it up. We'll see all this is doing is on return node. Well, on entry, we're getting direction. On return node, just the found boolean and chunk info, which is pulled from generating chunks at a key of a select. This goes into chunk info, that one goes into found. The select in the top direction will just be the top neighbor chunk coordinates. So if we're starting at 0, 0, we're at 0, 0, we want 0, 1, and that's done by getting our current chunk's position. Coming up here, sorry, this is a little bit a scary thing. I kind of thought it was fun. Um, we're going in the chunk x direction, making sure a vector out of it, and then adding one to the z direction. So each of these you just need to spend a little time to make sure. It's very simple. If it's the bottom, it's still the same x minus 1. If it's the left chunk, it's the x minus 1, maintaining that same z. And if it's a right chunk, the right neighbor chunk, it will be x plus 1. And all of those are plugged in to the select, which then is actually checking, sorry, inside here whether or not it exists. We're looking to see if we can find that within our generated chunks map. Now, if that is in the generated chunks, if that's true, then that means we care about, or we potentially care about, what has been generated within that chunk, and it will affect what we're trying to currently generate. So I've promoted the chunk info into a local variable and pulled out the tile map as a local variable. So remember, this is the neighbor's chunk. It's all of its information within our generated chunks, and so we want all of its collapsed cells. And from there, we need to do quite a bit of math. We'll see that kind of here. Actually, we're just going to end the video right here so I can prepare things properly. So I will see you in the next video.